we are going to look at solving radical expressions. Specifically, we're going to be solving expressions with square roots and cube roots in them, both equations and inequalities. Now, what is a radical equation? Well, that's going to be an equation that contains a variable inside of the radicand. So if you have the square root of x plus 2 in an equation, that becomes a radical equation. Now, what I need you to understand that with radical equations, we can have what are called extraneous solutions. Because within our radical, we have constraints, like we can't have negatives under the square root, that leaves us sometimes with an extraneous solution. An extraneous solution is a solution that does not satisfy the original equation, usually because it would make it negative in a square root. So let's look at what we want to do. So we have the square root of y minus 2 minus 1 is equal to 5. Now, when you start these, you want to always isolate the radical. Now, if you have more than one radical, it's usually easier to put them on both sides and put the simpler one with a side with any constants. But your first step is to isolate the radical. So I'm going to add 1 to both sides here so that I have the square root of y minus 2 is equal to 6. Now, the inverse operation of a square root would be a square. So I'm simply going to square both sides of this equation to get rid of the square root. Now remember, I've done this after I isolated my radical. So the square root of y minus 2 squared is simply going to be y minus 2, and 6 squared will be 36. Now I'll go ahead and finish this solution by adding 2 to both sides, leaving me that y must be 38. Now remember that we may end up with extraneous solutions. So for that matter, I'm going to always check my answer. So I'm going to check and substitute 38 in for y. So 38 minus 2 is 36. The square root of 36 is 6. And 6 minus 1 is 5. And you can see that's what I started with in my original equation. So I do have one solution, and that solution is 38. All right, so let's look at my second example here. So you can see in this problem, I have 2 radicals. Now I'm going to leave them on both sides. So my rule of isolating the radical in this equation is going to be a little difficult because I have 2. So I'm going to leave those split. Now watch and see what we're going to need to do. Now the first thing, since I have this larger radical isolated, I'm going to square both sides. Now here's where I need you to be careful. Remember that this is a binomial and you're not going to just square both terms. You are going to get from the left side the square root of x minus 12 squared is going to remain x minus 12. But the right-hand side, I'm going to have to multiply this by itself. So that's going to start a foiling process. So I'll take outer, and inner gives me negative 4 square roots of x plus x. Now you can see where I am. I got rid of most of my radicals, but I still have 1 to contend to. So now that I am down to 1, I'm going to go ahead and isolate that radical, just like I did in the first equation. So I'm going to take an x off of both sides. Now that's actually going to get rid of those x's. I'll have negative 12 equals 4 minus 4 square roots of x. I'm going to subtract this 4, leaving me with negative 16 equals negative 4 times the square root of x. Then I'm going to go ahead and divide both sides by negative 4. That leaves me with 4 is equal to the square root of x. Once I have isolated that radical, I'm going to go ahead and square both sides for the second time. So you can see that sometimes you're going to have to square more than once. This is going to give me 16 is equal to x. Now, I want to check that to make sure my solution is not extraneous. So I'll go back to the original and plug that 16 in. So the left-hand side, I get the square root of 4, which is 2. Now I'm going to work on the right-hand side. So I have 2 minus the square root of 16, leaves me with 2 minus 4, and that is a negative 2 on the right-hand side. These are not equal, and for that reason, this would be an extraneous solution. So for this problem specifically, I'm going to answer no solution. Okay, because my answer that I found did not work with my radicals because it made that side negative. Always go back and check to make sure everything works. Okay, let's look at our third example today. Now our third example says that this is to the 1/3 power. Now the 1/3 power is just a fancy way to write the cube root of 3y plus 1 plus 5 is equal to 0. Now just like I did in the last two examples, if I'm able, I'm going to isolate the radical. And in this problem, I only have one radical, so I'm going to get that by itself. So I have a cube root of 3y plus 1 is equal to, I'm going to subtract 5 from both sides, which is negative 5. Now, if this was a square root problem, I would be worried because I can't get a square root of a negative, but it's a cube root, so that's allowed, no worries. So to undo that cube root, I am simply going to cube both sides, and the cube root will undo itself, leaving me with 3y plus 1 on the left, and negative 5 to the third power will be negative 125. I'll go ahead and finish the solve by subtracting 1, leaving me with negative 126. Dividing both sides by 3, and y is going to be negative 42. Now once again, I want to check that solution. So I'm going to make this 3 times negative 42 plus 1, and then I will cube root that and add 5. So 3 times negative 42 is negative 126 plus 1 is negative 125. And the cube root of negative 125 is negative 5, and negative 5 plus 5 is indeed 0. So therefore it checks, and y is equal to negative 42 is my solution. All right, let's look at one last problem today. Now this is going to be an inequality, and for the most part, we're going to solve this one the same way, but when we get down to the check, I need to explain our extra constraints that we will have. So again, I'm going to isolate. So I will subtract 4 from both sides to isolate. That leaves me with 3x minus 6 is less than or equal to 3. Now I'll go ahead and undo the square root once it's isolated and square both sides. That will leave me with 3x minus 6 is less than or equal to 9. We'll go ahead and add 6. I'll have 3x is less than or equal to 15. Divide both sides by 3, and x is less than or equal to 5. Now, if you can see that this is saying that x could be any value less than 5, but we know that with radicals we have constraints. Because if I just go by this solution alone, x could be negative 10, x could be negative 40, x could be negative 1/2. What I need to do is check the constraints of this problem. that means that I need to check my radical and check what would make it negative. So I'm going to set the radicand again greater than or equal to 0, like we did when we started to graph our radicals. So I'm going to make 3x minus 6 greater than or equal to 0. This is going to set the constraints of what I'm allowed to have in my radical. I'll go ahead and add 6 to both sides. That's going to leave me with 3x is greater than 6. Divide by 3. Now my constraints on this side says that x has to be greater than or equal to 2. So if I'm looking at this on a number line, 2, 3, 4, 5. I'll put a couple more numbers in there. All right, my left-handed constraints say that x has to be greater than or equal to 2, so it has to go this way. My left-handed constraints say that x has to be less than or equal to 5. So my solution's going to be anywhere in the middle of those two. So I'll state my solution that x has to be a value that's less than or equal to 5, but it has to be greater than or equal to 2. So with the inequality, specifically the square roots, you're going to have to look at your constraints. With cube roots, that won't be a problem because cube roots has all real numbers in the domain system. All right, I'm going to give you some problems to practice, and if you have any questions, please send me an email. I hope you all have a great day.